Hello everybody. Today our math learning target is I can compare and order decimals to the hundredths place. Say it with me. I can compare and order decimals to the hundredths place. So first, let's make sure we understand every part of that learning target. The first part says I can compare. That word compare, when we say compare, we're thinking is something less than, and that's the less than symbol, equal to, and that's the equal symbol, or greater than, and that's the greater than symbol. So it's something less than, equal to, or greater than something else. So let's start quickly with some examples that you already know. Is 5 less than, equal to, or greater than 3? Is 7 less than, equal to, or greater than 100? And is 10 less than, equal to, or greater than 5 times 2? And I hope you said that 5 is greater than 3. That 7 is less than 100, and that 10 is equal to 5 times 2. So again, that's what we mean by compare. We just compared 5 and 3. 5 is greater than 3. We compared 7 and 100. 7 is less than 100. And we compared 10 and 5 times 2, and 10 equals 5 times 2. But the learning target doesn't just say I can compare. It says I can compare in order. So let's focus in on that word order. Order just means when you're given numbers, 3 or more numbers, to put them in order from least to greatest, the least to greatest value, or from greatest to least. So here we're given 3 different numbers. We're given 3, 2, and 8, and we're going to put them in order from least to greatest, or greatest to least, and greatest to least. So again, when we see that word order, it means put them in order. And if we're going to take 3, 2, and 8 and put them in order from least to greatest, there you have the least number 2, then you have 3, then you have the greatest number 8. Notice that we separate them by commas when we put them in order. So 2, 3, and 8 from least to greatest, we've separated them by commas. And then we're going to put them in order from greatest to least. So there we have 8, 3, 2 from greatest to least. So in our learning target, what are we comparing or putting in order? And let's focus in on that word, decimals. So what are decimals? Well, decimals are just fractions written in a different way. And in the last lesson, you wrote or expressed decimals as fractions. So for example, here, just as a refresher, 0.32 or 0.32, we could write that as a fraction. Pause the video for a second and think about what you'd write that, how you'd express that as a fraction. So 0.32 is equivalent to or the same as 32 hundredths. Well, 32 hundredths is a fraction, so is 0.32. It's a decimal, which is the same thing as a fraction. So there's no difference. It's just 0.32 is a fraction written in a different way. It's still 32 hundredths. And even though in the lesson from this past Monday, you were able to express decimals to the thousandths place as fractions, we're just going to be working up to the hundredths place, which is the 4th grade standard, at least for today. And when we say I can compare and order decimals to the hundredths place, that means that we might find fractions that are in the tenths place, and we might find fractions that are in the hundredths place. That's what to the hundredths place means. But whether the fractions to the tenths place or in the hundredths place, we're going to be able to put them in order, partly by using what we already know or already should know about fractions. Well, something we should already know about fractions is that the denominator tells us how many equal parts the whole's divided into. So here for the fractions 2/4 and 3/4, each have a denominator of 4, which means that our whole is divided into 4 equal parts. And it also means that in 2/4 and 3/4, each of the 4 equal parts in 2/4 is the same size as each of the 4 equal parts in 3/4. So that makes it easy to compare 2/4 and 3/4, because the numerator in 2/4, 2, tells us that we have 2 of those same sized 4 equal parts, and the numerator in 3/4 tells us that we have 3 of those same sized equal 4 parts. So is 2/4 less than, equal to, or greater than 3/4? That's right, 2/4 is less than 3/4, because if we have 2 of the same sized parts, it's going to be less than 3 of the same sized parts. So when you have the same denominator, or also called a common denominator, here 4, the fraction with the lesser numerator is less than the fraction with the greater numerator, because the whole's divided into the same number of equal parts, and the fraction with less of those equal parts is less than the fraction with a greater number of those equal parts. So 2/4 is less than 3/4. So the same principles apply here when comparing decimals. Remember, decimals are just another way of writing fractions. And if you remember from last lesson, if we look at 0.4 and we look at 0.8, what fraction could we express 0.4 as? If you said 4/10, you're right. What fraction could we express 0.8 as? If you said 8/10, you're right. So if I ask you to compare 0.4 and 0.8, again, if I ask you to compare 0.4 and 0.8, really what I'm asking you to compare is 4/10 and 8/10. And notice the denominator is the same in both of those fractions. It's tenths, which means our whole's broken into 10 equal parts for both of those fractions. But in the first fraction, 0.4 or 4/10, we only have 4 of those same size parts. And in the second fraction, 0.8 or 8/10, we have 8 of those same sized parts. So are 4 of those same sized parts or 8 of those same sized parts greater? Which one's lesser? Which one's greater? Right, 4/10 is less than 8/10, which also means since 4/10 and 0.4 are the same, and since 8/10 and 0.8 are the same, that 0.4 is less than 0.8. And I'm not sure if that came out just now in the video. So since 4/10 is less than 8/10, and 0.4 is the same as 4/10, or equivalent, 0.4 is equivalent to 4/10, and since 0.8 is equivalent to 8/10, if 4/10 is less than 8/10, then 0.4 is less than 0.8. Because 0.4 and 4/10 are the same thing, and 0.8 and 8/10 are the same thing. So now I want to compare 0.63 and 0.59. Well, I want to think, how can I express 0.63 as a fraction? Or in other words, what fraction is it equivalent to? And how can I express 0.59 as a fraction? Hopefully you remembered from last lesson that 0.63 is the same as 63 100ths, or 63 hundredths, and 0.59 is the same as 59 hundredths. So again, looking at 63 hundredths and 59 hundredths, the denominator is the same for both of them. They have a common denominator, so it's easy to compare them. 63 of the same size parts is greater than 59 of the same size parts, and we know they're the same size because both wholes are broken into or divided into 100 equal parts. So if we have 63 of them, that's greater than 59 of them. And if 63 hundredths is greater than 59 hundredths, then 0.63 is greater than 0.59, because 0.63 is 63 hundredths, and 0.59 is 59 hundredths. So we're about to get to the really fun part. First, I just want to review, and if you maybe didn't learn it this way, teach you. Here, if we're comparing 2/4 and 3/8, we don't have the same denominators, and here it would be easy to find a common denominator. We could express 2/4 as a fraction with a denominator of 8, and this is the way that I taught the students in room 13 to do that. So like I said, we want to express 2/4 as a fraction with a denominator of 8, so we can easily compare it to 3/8 that already has a denominator of 8. So to do that, I like saying 2/4 times what equals something with a denominator, a fraction with a denominator of 8. And whenever you multiply a fraction by the same numerator and denominator, you're going to get an equivalent fraction, or in other words, a fraction that is exactly the same amount. So if you look at this, on the denominator, 4 times something is 8. And whatever we get there, we're going to put in the numerator too, because again, you only get an equivalent fraction when you multiply a fraction by the same numerator and denominator. So 4 times what is 8? That's right, 4 times 2 is 8. And again, since we have to multiply 2/4 by the same numerator and denominator to get an equivalent fraction, we're going to multiply 2/4 times 2/2. And on the numerator, we're going to get 4. And so that means that 2/4 equals 4/8. Said another way, 2/4 is equivalent to 4/8, or 2/4 is 4/8. If 2/4 is 4/8, then I can just express it that way. So notice under the part where I'm comparing 2/4 and 3/8, I express 2/4 as its equivalent fraction, 4/8, and I compare 4/8 and 3/8. We know that 4/8 is greater than 3/8, so the equivalent fraction to 4/8, 2/4, is also greater than 3/8, because 2/4 and 4/8 are equivalent. Now pay close attention here. We're going to compare 0.4 and 0.28. So 0.4 is 4/10 and 0.28 is 28 hundredths. Again, 0.4 is 4/10 and 0.28 or 0.28 is 28 hundredths. So 4/10 and 28 hundredths, but we don't have the same denominator. So it's not that easy to compare them. But you might notice that it would be quite easy to express 4/10 as a fraction with a denominator of 100, using the same strategy we just used a little bit earlier. So to express 4/10 as a fraction with a denominator of 100, we can set it up this way. And it kind of now maybe looks a little bit easier, because most of us know on the denominator that 10 times what equals 100. 10 times 10 equals 100. So to express 4/10 as a fraction with a denominator of 100, remember, in order to find an equivalent fraction, you need to multiply it by the same numerator and denominator. So we're going to multiply 4/10 times 10/10, and we're going to get how many hundredths? 40 hundredths. So 4/10 is the same as, is equal to, is equivalent to 40 hundredths. So now that we've expressed 4/10 as 40 hundredths, an equivalent fraction, when we compare 4/10 and 28 hundredths, or 40 hundredths and 28 hundredths, same thing, we could easily see that the 40 hundredths is greater than 28 hundredths, which means that the equivalent fraction 4/10 is greater than 28 hundredths, because 4 tenths and 40 hundredths are equivalent fractions. And 0.4 is the same thing as 4 tenths. So that means that 0.4 is greater than 0.28. 0.4 is greater than 0.28 because that's the same thing as saying 4 tenths is greater than 28 hundredths. 4 tenths is greater than 28 hundredths because 40 hundredths is greater than 28 hundredths. So let's start moving a little more quickly now. I don't think you need the place value chart. We have 0.18 and 0.3. We want to express them as fractions. 0.18 is 18 hundredths and 0.3 is 3 tenths. Still kind of hard to compare them because we don't have a common denominator. Which one are we going to change? Are we going to change the denominator of hundredths to tenths, or tenths to hundredths? And if you said tenths to hundredths, you're correct. So we're going to want to express 3 tenths as a fraction with a denominator of 100, so we can easily compare it to 18 hundredths, which already has a denominator of 100. To do that, we're going to use the same strategy we're using. 3 tenths times what over what equals something over 100. And when we're going from tenths to hundredths, we're always going to end up multiplying by 10. So we'll always multiply that original fraction that we had, or the way we saw it the first time, 3 tenths, whatever it is, to get to hundredths by 10 tenths. And here we'll get 30 hundredths. So 3 tenths is 30 hundredths. 18 hundredths is what? Then 30 hundredths is less than. So if 18 hundredths is less than 30 hundredths, then 18 hundredths is less than 3 tenths, because 3 tenths and 30 hundredths are the same thing. They're equivalent fractions. That also means that 0.18 is less than 0.3, because 0.18 is 18 hundredths and 0.3 is 3 tenths. The next example I want to take a look at is one where if you kind of don't think of it very carefully, it might be easy to make a mistake. Because when we look at 0.3 and 0.08, you might just look at the digit 3 and then at the digit 8 and think, well, the digit 8 is greater, so 0.08 is greater than 0.3. But that's not correct. And so let's do this the way that we would normally do it. First, you want to express each decimal as a fraction. Think about what those fractions would be for a second. And that's right, 0.3 is the same thing as saying 3 tenths. And 0.08 is equivalent to 8 hundredths. And before we even go any further, just trying to figure this out, in 3 tenths we have a part that's broken into 10 equal parts. In 8 hundredths, we have a whole that's broken into 100 much smaller parts, because it's the same whole, just broken into way more parts. So if you have 8 of those way smaller parts versus 3 of those much bigger parts, it's kind of makes sense that 3 tenths would be greater than 8 hundredths. But let's see why. So just like we did before, to compare those fractions, we want to express both fractions with a common denominator. And so it's going to make much more sense to express 3 tenths as a fraction with a denominator over 100, because 8 hundredths already has a denominator of 100. So what would be our first step? Just think about it. I'm going to go ahead and do it in a second, but think about what you would do first. So like we've done before, we take 3 tenths, we multiply it by 10 tenths, and we're going to get how many hundredths? That's right, 30 hundredths. And so now we can easily compare 30 hundredths and 8 hundredths. They both have the same denominator. They have a common denominator. And 30 hundredths is what then 8 hundredths? 30 hundredths is greater than 8 hundredths. And that means that 0.3 is greater than 0.08. Why? Because 0.3 is equivalent to 3 tenths. 3 tenths is equivalent to 30 hundredths. 30 hundredths is greater than 8 hundredths. So 0.3 is greater than 0.08. So now I want you to try a couple on your own. I want you to compare 0.39 and 0.6 using the same strategy we just tried. And then after you do that, I want you to compare 0.02 and 0.1 using the same strategy. So go ahead and pause your video. So hopefully when comparing 0.39 and 0.6, you recognize that 0.39 can be expressed as 39 hundredths, and you recognize that 0.6 could be expressed as 6 tenths. Then you also recognize that you can't easily compare 39 hundredths and 6 tenths because they don't have the same denominator. And you hopefully realize that you should express 6 tenths as a fraction with a denominator over 100. Then looking down at the fractions we have 39 hundredths and we have 60 hundredths. And when we're comparing 39 hundredths and 60 hundredths, wholes broken into the same number of equal parts. On the one side we have 39 of them, on the other side we have 60 of them. So 39 hundredths is what then 60 hundredths? 39 hundredths is less than 60 hundredths, and therefore 0.39 is less than 0.6, because 0.39 is 39 hundredths and 0.6 is 6 tenths, which is also 60 hundredths. They're all equivalent. Now hopefully when comparing 0.02 and 0.1, you recognize that 0.02 is 2 hundredths, and that 0.1 is 1 tenth, and you also hopefully recognize that you need to express 1 tenth as a fraction with a denominator over 100. So 1 tenth expressed as a fraction over 100 is 10 hundredths on the right side there. And now we can compare 2 hundredths and 10 hundredths, and 2 hundredths is less than or greater than 10 hundredths. 2 hundredths is less than 10 hundredths, and therefore 0.02 is less than 0.1, because 0.02 and 2 hundredths are the same. They are equivalent. They're the exact same thing, the same amount. And 0.1 and 10 hundredths are the exact same amount, because 0.1 is the same as 1 tenth, and 1 tenth is the same as 10 hundredths. Okay, so your exit ticket for today is going to be to do the following 4 problems. Compare 0.36 and 0.29, then compare 0.3 and 0.29, then compare 0.4 and 0.09, and then compare 0.06 and 0.6. For each of those, for example, when you're working on number 1, make sure you express the decimals as fractions. If they already have the same denominator, great. But if they don't have the same denominator for each one, make sure you express any fraction with a denominator of 10 as a fraction with a denominator of 100, just like we did in the examples, and then compare them. So in other words, I want you to set up each of these problems the same way that I set them up in the examples right before the exit ticket, to show me that you understand what you're doing and that you understand your work. You'll notice today that we only got to the part of the learning target I can compare decimals to the hundredths place. So our next lesson is going to be I can order decimals to the hundredths place. I'm going to probably ask that you do this exit ticket tonight, which is Wednesday, and that you do the next exit ticket putting decimals in order on Thursday night on Thursday to Friday. They're both going to be due Friday. But if you finish this one tonight, you could always send it to me and I can check whether you understood or whether you need a little bit of help before you start the one tomorrow. Okay, thanks. Have a great day. Talk to you later.